Good morning. Today we are going to learn how to calculate empirical formulas. We're going to use the percent composition that we calculated in our bell work for aluminum nitrate and show how we can work from that back to the original formula using the steps for calculating percent composition. So first of all, for the bell work, just to remind you what you should have gotten, we had aluminum nitrate. Aluminum is 26.98, and I only had one of those. I've got 3 times 1, 3 nitrogens, so 3 times the atomic mass of nitrogen gives me 42.03 grams. And then I've got 3 times 3, 9 oxygens. Remember, you do multiply that in case you only had 6. When I add all those up, I get 213.01 grams. Now I'm simply just going to divide each of my individual elements' totals by that overall molar mass of 213.01. And then to make it a percent, I'll multiply by 100. And what you should have gotten, give or take, you may have kept 3 after the decimal, so that may have given you a slightly different number. But I got 12.67% aluminum, 19.73% nitrogen, and 67.60% oxygen. That was the bell work. That is something we have already done. So how can we start here and work back to the formula? So let's start this again, but this time let's look at what we would do if we knew the percentages and we wanted to get back to the formula. So the question we would be answering would be, what is the empirical formula of a compound composed of 12.67% aluminum, 19.73% nitrogen, and 67.60% oxygen? Well, if you look at the steps I had you write in your notes, the very first step is to treat these percentages as grams. Why can we do that? Well, if I had 100 grams of this substance, 12.67 grams of that would be aluminum, 19.73 grams of that would be nitrogen, and 67.60 grams of it would be oxygen. Why is that accurate? Well, remember, these percentages were based on masses to begin with. So they are a representation of the percent by mass in that compound. If you read the second step, what does it say to do? It says to convert those gram quantities to moles. So our second step will be to convert each of these to moles. So remember, if we're starting at grams, grams will go on bottom, moles will go on top. What number always goes with moles? 1 in a conversion. And where do we always get the number for grams? Well, that's from the molar mass on the periodic table. So if we look up aluminum, it's 26.98. Nitrogen is 14.01, and oxygen is 16.00. So we're going to go ahead and do the math for this. 12.67 times 1 divided by 26.98. Now I want to keep all 4 sig figs. This will make my answer come out much more neatly. So for this, I get 0.4690 moles of aluminum, 19.73 divided by 14.01. 1.40 8 moles of nitrogen and 67.6 divided by 16, 4.225 moles of oxygen. So we've done the first 2 steps, treat the percentages as grams, convert those grams to moles. The third step is to divide through by whichever of those is smallest. Remember, in formulas, it's always a whole number ratio. So in order to get this closer to a whole number ratio, if we divide through by the smallest, then the smallest becomes 1. That's the minimum amount of an atom you can have in a compound. So if we divide through by the smallest, we're going to get closer and maybe all the way to a whole number ratio. So of 0.469, 1.408, and 4.225, the smallest is 0.4690. So we're going to divide each of these by 0.4690. Remember, in a ratio, whatever you do to one, you have to do to the other in order to maintain that ratio. And this will obviously come out to 1 mole of aluminum. If I take 1.408 divided by 0.4690, I get 3.002 moles of nitrogen. 4.225 divided by 0.4690 gives me 9.008 moles of oxygen. Now, this has actually come out pretty cleanly because the rule is you don't want to be more, you can round to a whole number as long as you're not more than about 0.01 or 0.02 off. And I'm not off in the hundreds, right? Actually, if I rounded that, it would be 9.01. And that's close enough to a whole number to round. So this would round to 3 moles of N and 9 moles of O. Now, this is not my ultimate answer. My ultimate answer is to take this information and put it into a formula. In general, you are provided the percentages in the order that they should go in the formula. So I'm going to write aluminum first, nitrogen second, and oxygen third. So how many aluminums do I have? 1. But have you ever seen a 1 in a chemical formula? No. As long as you put the element there without a subscript, it's assumed to be 1. Then I'll put nitrogen. And what subscript will it need? A 3. And then I'll put oxygen, and it will need a 9. Now, is this exactly like our original formula? No. But are the ratios the same? Well, I've got 1 aluminum, 3 nitrogens, and 3 times 3, 9 oxygens. So as you get familiar with some of these ions, you'll know that that's really the same as this. But this answer is as far as you need to be able to figure out. So let's try one more, and then I will let you try some on your own. So let's say that we have a compound. What is the empirical formula of a compound composed of 43.65% gallium, 11.31% carbon, and 45.07% oxygen. So first step, remember, treat those percents as grams. So 43.65 grams of gallium, 11.31 grams of carbon, 45.0 grams of oxygen. After we treat the percents as grams, our next step is to convert those grams back to moles. Since we're starting with grams, those will go on bottom. We're converting to moles, so that will go on top. And then we just need to put the molar masses on bottom. For oxygen, that's 16.00. For carbon, its atomic mass is 12.01. And for gallium, it's 69.72. So remember, you want to keep all your sig figs. 43.65 divided by 69.72. This gives me 0.6261 moles of gallium. 11.3 divided by 12.01 gives me 0.9409 moles carbon. 45.07 divided by 16 gives me 2.817 moles of oxygen. So we treated our percents as grams. We converted those grams to moles. Now our third step is always going to be to divide through by whichever is the smallest. Well, of these three, the smallest is gallium. So I'm going to divide them all by 0.6291. Whatever you do to one part of a ratio, you must do to the rest of the ratio. Remember, this is just getting me to closer to a whole number ratio. In our first problem, it took us all the way to a whole number ratio. So 0.9409 divided by 0.6291. This gives me 1.500 moles of carbon. 2.817 divided by 0.6291 gives me 4.478 moles of oxygen. Now, bad news, sorry about that. It takes my camera a second to catch up. So this is not close enough to a whole number to round, right? I do have a 1 here and I have a 1.5, but they have to be really close to a whole number. So occasionally you have to take a last step and multiply through by another whole number to get to a whole number ratio. And sometimes the easiest way to do that is just to play with it a little. So for example, if I multiplied these by 2, this becomes 2. This would become 3. And this would become 8.96. That is close enough to round. So let me move this up just a little bit. So here, our formula, 2, 3, and 9, that would round to 9. So this would be gallium has a 2, carbon will have a 3, and oxygen will have a 9. Now, most of the ones that you're doing initially, you don't have to multiply through. Remember, if you're more than about 0.05 away from a whole number, you're probably gonna, or maybe closer to 0.10. If you're within 0.05, you're okay. But if you're too far off, you'll have to multiply through. Most of the ones that you'll do, though, are going to come out more cleanly, like the first one we did, where all of your numbers come out nice and close, 1, 3, and 9. Those came out really close. So we're going to do one more together, and I'll let you use it as an example, and then I'm going to have you try a few on your own. Good luck, and thank you for listening.